Hello guys, welcome to my YouTube channel. um Please, I want to let you guys know that if you find my videos helpful, please don't forget to like and subscribe to my channel. So let's get started. Firstly, we're going to build what we call a quadratic equation solver. So firstly, before you came across this video, you must have known what a quadratic equation is. So an equation that is characterized by ax squared plus bx plus c is equals to 0. So something like that is a quadratic equation. So we want to develop a quadratic equation solver whereby you put in your a value, your b value, and your c value, and you'll be able to get your roots. Now, for us to do this, we're going to be needing the discriminant. The discriminant, and how do we calculate for the discriminant? We use b squared minus 4ac to get the discriminant. Now, if the discriminant is positive, that means it's greater than 0. The equation has two distinct real roots. So if the discriminant is 0, is equals to 0, then the equation has two identical real roots. And if the discriminant is negative, which means the value for the discriminant is negative, which is less than 0, the quadratic equation has two complex roots. So this idea will shaping the way we're going to be designing our quadratic equation. So the first thing we're going to quadratic equation solver. So the first thing we're going to do is to import math. So this line, import math module, it's a module that provides the mathematical functions and constants in Python. So that's why we're going to first import math. So the next thing that we're going to do, we're going to define solve quadratic. So we're going to define solve quadratic. Solve quadratic. Solve quadratic. We're going to put the coefficient a, b, and c. Now we have import math, the math module. We have defined solve quadratic. We are now going to look at the discriminant that we talked about earlier. So the solve quadratic is going to take three parameters, which is a, b, and c. That's what we're seeing on the screen. So these parameters is based on what is going to take as input, like ax squared plus bx plus c is equals to 0. So as we said, the discriminant of a quadratic equation is calculated using the formula b squared minus 4ac. So one of the reasons why we calculate it is to determine the nature of the roots of that quadratic equation. And before we go into that, now first let's try to define the discriminant. So we can say discriminant is equals to b square. So our square in this case, we're going to use double star b square minus 4 multiplied by a, and multiplied by c. This is our discriminant. So now we have already defined our discriminant, and I said earlier that our discriminant will help us know the kind of root that the nature of the root that our quadratic equation is going to give us. So now we are going to be handling the two cases of the root. You know, the quadratic equation is b square plus or minus. So we are going to, sorry, the quadratic equation formula is minus b plus or minus the root of b squared minus 4ac over 2a. So we're going to first take the minus b plus the root of b squared minus 4ac over 2a. I'm going to take the minus b minus the root of b squared minus 4ac into account in this case. And so we're going to be doing that shortly now. So I'm going to say for root 1, that's okay. Let's continue from here. Let's use the if statement. If discriminant is greater than 0, so if our discriminant is greater than 0, then we can say our root 1 is equals to minus b plus, so minus b, sorry, I made a mistake there, minus b plus math dot square this math dot square into brackets the discriminant. I'm going to close the bracket, right? We're going to divide this by 2 multiplied by a. That's for our first root. For the second root 2, the second root, we're going to repeat the same thing. But this time around it's going to be negative. So minus b minus math dot square into bracket the discriminant, then divided by 2 multiplied by a, close the bracket. I think this one should also be like that, 2 multiplied by a. Yes, so we have defined as our root. So this is, our discriminant is equals to b squared minus 4 multiplied by a and multiplied by c in this case. So what we are doing here is simply minus b plus the square root of the discriminant, this divided by 2 multiplied by a. That's what we are doing here. So we now say return our result. It should return, this code should return the root 1 comma root 2. So it's going to return 2 roots, which are root 1 and root 2. So now we're going to use an elif statement saying that if discriminant is equals to 0, so if discriminant is equals to 0, then the roots will be minus b divided by 2 multiplied by a. Yes. Then I'm going to say return root. Root. So we're now going to use an else statement. I'll say else. I'm going to say the real part. The real part is equals to minus b divided by 2 multiplied by a. The imaginary part will be imaginary part will be equals to maths dot square, that's square root absolute. Then we're going to say discriminant. Now I'm going to close the brackets. Now I'm going to say multiply by 2 star e star e. So I'm going to say root 1 is equals to complex real underscore part and imaginary underscore part. You can say root 2 is equals to complex real part, comma, and then imaginary part. So I'm going to say return root 1, comma, root 2. So we're going to say print. Let it now print. You should print the quadratic solver. This is what we're going to see on our interface. Print quadratic equation solver I'm going to close the bracket. So you're going to say A I'm going to say A is equal to float into bracket input, then enter the first value, enter the coefficient of x squared. So enter the coefficient of x squared. X, that's x to the power 2. How do we write this? That's x squared. Okay, x squared. Then we're going to put x squared here. Then we're going to say a, that's our a. So we're going to close the bracket. We're going to say b equals to, as well, float input enter the coefficient of x into b and then we're going to close the bracket as well, and then we're going to say c float input. We're going to say you should enter the coefficient sorry, there's no coefficient in this, in the c part. It should be the constant c, the constant term c in this case. And then we'll close the bracket. So what else again? So we're going to say again, if instance root comma complex, would you print root 1 and root 0? Okay, let's do this way. Let's say if, for us to cater for the complex root, in this case, let's say if instance of root of root 0 complex it should print root 1, the root of 1, and root of 0. which also print root root of 1. Let me see, am I writing the correct thing? Okay, I think I need to put the S here. We can now say in this case else print root 1 root 0. Then print root 2 root of root 2, then root of 1. Yes, so we're done with our code, I think. So let's quickly briefly do what we call a recap. So firstly, we imported the math module at the beginning. So it's a module that provides mathematical function and constants in Python. So later we said define, solve, quadratic, that's A, B, and C. So this solve quadratic takes in 3 parameters, A, B, and C, which are the coefficient of the quadratic equation ax squared plus bx plus c. Then we calculate the discriminant using b squared minus 4ac to determine the nature of the root. Like, is it a quadratic equation with complex root? Is it a quadratic equation with identical real root, or is it a quadratic equation with real root? So that's the function of the discriminant. Then we use we imputed the quadratic equation itself. We said if discriminant is greater than 0, so the quadratic equation formula applies: minus b plus the square root of the discriminant, which is b squared minus 4ac divided by 2 multiplied by a. Then we did for the root 2 minus b minus the square root of the discriminant, which is b squared minus 4ac divided by 2a. Then we use elif for the second discriminant in this case, and the elif function here is to provide alternative, which is in this case, what of elif means in this case, if is equals to 0. So we said if two quadratic equation, if the discriminant is equals to 0, then the equation will have 2 identical real roots, as we said. So we used elif if discriminant is equals to 0, then the root will be minus b divided by 2 multiplied by a, and it's going to return root. So we now say else, which should be the third one. So else, we said the real part is minus b, divided by 2 multiplied by a, and the imaginary part, we did that. So root 1 is complex of real part, imaginary part. Root 2 is complex of real part and imaginary part. So if the discriminant is greater than 0, the equation has 2 real and distinct roots, which is calculated from the quadratic formula. So if the discriminant is equals to 0, the equation have 2 real identical roots, and that's what we use the elif here for. And if the discriminant is less than 0, the equation has complex roots, and so we calculate them according using the complex number, and that's what we did in the else in this case. Now, as I've said, this print statement here is for the command input. So it's going to put a print message to the user and prompt them to input the coefficient of a, b, and c. That's simply what this is trying to do. And then from there, it's going to solve the quadratic equation. So after it has gotten the coefficient of a, b, and c, it's going to call the solve quadratic function with the input coefficient a, b, and c, and store the return roots in their variable root. So later, after that, it's going to now use this statement, the if is instance, all the statement here is going to use it depending on whether the roots are complex or real. It will print them out accordingly according to the roots. So if they are complex, we print them in complex number. If they are real, it's going to be printed in real number. So let's try to run this code. Let's see how it works. Let's see if it's going to run. Oh, as usual, we got our first error, which is on line 12. Line 12, what do we have in line 12? Let's see. Let me close. Let's see line 12, line 12, line 12. We have else in line 12. Else in line 12. I think that's correct. Let me see. Else in line 12. Yes, it's correct. Okay, I didn't put this column. Yeah, I think that's the reason. Let's rerun again. We have in line 19 an error in line 19. And line 19 we say print quadratic equation solver, and what's the problem? There's no problem with it, I think. Let me run it again. Line 28, let's see what's happening. Line 28, we use else, we don't put the semicolon, we didn't put the okay, the colon there. What else again? Let's try to rerun our code. Yeah, finally we are able to run our code. So it's asking for the value, the enter the coefficient of a squared, in this case 34. Let me also be present on my calculator to be sure that this our calculator is giving us the correct answer. So let me select equation on my calculator, quadratic equation. So I'll be entering it as well. 34. It says the second coefficient, let's say 5. There's an error in 23. Line 23, let's go back to line 23. Let's see what the error is. In line 23, we see that c is equals to float input. Let's correct this input. Then enter. Okay, let's correct this. Let's try to rerun the code again. So let's use 34 as usual. let's use 5 for our B. Yes, and so our C, let's use 6. Let's use 6. This should supposed to give us a complex root. Okay, there's line 25. What's happening in line 25? Let's see what's happening in line 25. It's giving us an error. It's trying to call a function, but there's an error with the calling. Let's see what's happened. Yes, complex. What happened to line 25? Line 25 is okay. Line 26, print the roots. Yeah, it's correct. This is correct. So what's wrong? That's 4, 5, and 6, 18. The root and is not defined. The root is not defined. The root is not defined. The root is not defined. Let me see. Having some issues right here. I don't know what's wrong with the code. The code looks fine by me. Still trying to see if there's a little mistake anywhere. I should run this our code again. Enter coefficient 34. Let's say 5 and then this 6. It's saying that the root is not defined. In this case, root is not defined. Whoa. Let's go back to our equation. Let me remove this. Let's see if the root will be defined now. Let's run to the form. Similar thing. Let me review this my code to be sure, because I don't know why I'm getting that error, that kind of error. Let's go through this code again. Okay, we're going to include something here. So let's see if this will solve the problem. Root is equals to solve quadratic a comma b comma c. Let's see if it will solve this problem. So we have it at 4, having 5, we have in 6. Finally we're able to solve our problem. Yes. Wow, our calculator is working. Our quadratic equation solver is working. The answers were pretty accurate. I pressed it on my calculator, I got the same thing. Let's try another quadratic equation and try to solve it using this our calculator. Let's rerun again. Let's enter first value as 1, 2 and 3. Let's see what it gives us. It's also a complex this thing. So we can all see that we're able to develop a quadratic equation solver. If this video was helpful to you, please don't forget to like and subscribe to my channel. Thank you for watching. Have a great day.